In this session, we will try to uncover length and also another function called length. Let's try to look at length first. It is a final variable or identifier applicable only for arrays. It returns number of elements present in that array, or also known as size of array. Let's look at length function. It is a method which is present in predefined string class. It returns number of elements present in that string, or also known as size of the string. Let's look at some examples. For example, I have an integer, say a, and new int of size, sorry, and if I do a dot length, then I need to get the size of that array. Let's compile. Execute. I got the size of the array as 3. For example, if I use the length method, I would get compilation error. But let's try to compile. Yeah, it says cannot find a length method for array A. For example, if I have to use the length method, I will declare a string s and say new string. Say for example, and if I have to get the length, it should return how many elements are present in that string. Let's try to compile this. I need to change the variable name to as just taking the previous example, variable name A, and let me execute this. It's 4. So that's the difference between length and length method. Let's try to see both cases. Let's say if I change this to string array A and I declare, say for example, your name's here, Mike. Amy. And John Doe. And try to get the length of this array. We have 4 elements, the size of this array is 4. And let's say, for example, I need to get the length of first element in that array, A of 0, which is Mike, and I have to use length method for the string, and it's going to be 4 again. Let's do one more. Say that the length of Amy, it's going to be 3. Let's try to compile and execute. 4, 4, 3. That is all about length versus length function. Let's uncover what's called anonymous arrays. What are anonymous arrays? Sometimes we can create an array without name, such type of nameless arrays are called anonymous arrays. The main objective of anonymous arrays is just used for instant purposes. We can create anonymous arrays by using the syntax. So new int temp unique 30 is, for example, one dimensional, for example, 2-dimensional new int of then open parenthesis, open first one-dimensional array 10, 20, 30, 10, comma, maybe 40. This is how we can declare anonymous arrays. Let's see some examples. For example, I'll write one class to add sum of all the elements present in an anonymous array. So sum of A, call it A, whatever is sent to this class, and declare int sum is equal to 0, and for each int item, which is the element in that array, then sum is equal to sum plus item, the current item or current element. Then we have to return sum from this class. So here I'll take few anonymous arrays. Say for example, sum of new and 10, comma, 20, comma, 30. So it should give us 60. And say for example, I have another anonymous array like 40, 50. It should give us 90. That's another one. For example, 60, 70, 80, 90. 90, 70, 150, 90, 60, 150, and 80, 70, 150, total 300. Let's try to compile. Execute. We have 60, 90, and 300. Let's move on to next topic, which is array element assignment. So let's see some cases, like case 1. In the case of primitive arrays as element, any type is allowed. To be promoted to the declared type. Let's see with some examples. What does this mean? So let's say I have a byte v1 is equal to 10. And then say for example, I have a short v2 is equal to 20. Then let's say I have an integer and v3 is equal to 30. And let's say I have a long v4 is equal to 4. And then let's say I have a byte array called a new byte of length or size 4. Then a of 0, I can assign v1 because v1 is a byte. This is a valid example or a valid entry. If I have a of 1 is equal to v2, this is not allowed. Even if the value fits in the byte range, the data type of v2 is short and you cannot assign short to a byte array. So let's try to compile to see. So it says possible lossy conversion from short to byte. So v2, it's invalid. So now let's make this array the short. So we can assign byte, we can assign short, but let's try to assign element A2 with v3. And v3 is integer, so this is invalid. So let's try to compile this. It says incompatible byte cannot be converted to short. It's possible lossy conversion from int to short. For example, I change this to int, then v3 will become valid. But let's say I have a3 and assign v4, which is invalid because you cannot assign long to an integer array. So let's try to compile this. It says byte cannot be converted to int, lossy conversion from long to int. So from all these examples, what we can conclude is we can assign byte to a byte. We can assign a byte and a short. We can assign byte, short, and int to an integer. And then we can assign byte, short, int, and long to a long. Then we can assign byte, short, int, long, and float to a float. Then we can assign byte, short, int, long, float, and double to a double. For Boolean, you just have to assign Boolean, and for char, you can assign byte, short, int, and char. Okay, now let's move on. Case 2. So in the case of object type arrays as array elements, we can provide either declared type objects or its child class objects. Let's look at what this means exactly using an example. So let's say I have a class called student and another class test. We already have it. So for example, I have an object array A. We've got a new object of size 4. So A of 0, I can assign new object itself, which is fine. Say for example, A of 1, I can assign student class. I can assign test class itself to the next element. And I can also assign, say, for example, new string, say ABC. These are all allowed for an object array. So let me try to print system out print line. Arrays to string of A. Compile. I misspelled the string, 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 compile, and then execute. So it's printing the object address for object, then for student, it prints the student class address, and then it prints the test class address, and then it prints the string itself. So all these are allowed for object array. Let's take another example. For example, I have array number, the A, and new number of 4. A0, I can take it as new integer, says, say example 10. It is allowed because integer falls under numbers. And A1, I can take a double, that also falls under the numbers. And for A2, for example, if I take test, it's not allowed. And for string, that is also not allowed. Now let's move on to case 3. Case 3 is related to the interfaces. In case of interface type arrays, interfaces we will cover as we progress, but let's just for the sake of noting it down, giving it here. In case of interface type arrays as array elements, we can provide its implemented class objects. So, for example, let's take a runnable interface R is equal to new runnable of size 3. Then R of 0, I can take a new thread. We'll obviously uncover these in interfaces. Then R of 1. Say, for example, I want to take a string for interface array ABC. That's not allowed. This is invalid. So let's try to summarize what we have covered so far. For primitives, any type of values which can be promoted to declared type. For objects, either declared type and its I'll as objects. For interface, implemented class objects. For abstract class, its titled class objects are allowed. We'll get more clarity as we progress and cover interfaces. So let's move on to the next topic. It is array variable assignments. Element level promotions are not applicable at array object level. So for example, char, a value, can be promoted to int type. But character array cannot be promoted to int array. So this is valid. This is valid. Let's see this with an example. For example, I have an integer array A and I have 10 comma 20 comma 30. And say for example I have a character array called B, and let's say I have A, B, C. So int new array in C, for example, I can assign A to it, which is totally fine. And let's try to say print arrays to string A, comma, B, not B and C. So this should work perfectly fine. Let's compile and execute. I have 10, 20, 30, B, A, B, C, and then C, I have A in it. So 10, 20, 30. So if I try to assign B to this C, I will not be able to assign because I cannot assign char to an int. So let's compile and see. So it says char array cannot be converted to int. So let's try to conclude some conversions here. So char to int, it's valid. But if it is from char array, to int array, it's not valid, so it's invalid. So next, let's see, for example, int to long is valid. But int array to long array, it's invalid. For example, let's say double load. That's not allowed. It's invalid. Likewise, double array to float array is also not allowed. Now let's say, for example, string to an object. It's allowed. And even string array to object array is also valid. So in case of object type arrays, child type array can be assigned their type array variable. So, for example, I have a string array A, which is equal to, let's say, A, B. And if I assign this to object array called B is equal to A, this is allowed, this is valid. I'll stop here and continue.